All right, so I went through I went through a lot really with this whole wake word thing, and it becomes like actually what we were just talking about, the AI thing. I'm using the machine learning chip that's built onto the phone,
Nice.
and it's called Core ML. And here I can show you. This is pretty cool.
All
Um,
right, let me give you a screen.
all right, so this is pretty neat. Um, you can like have to let it like build up some background noise, which is whatever. And like I already did this, so I'm just showing you. It's kind of cool though. Then you give it like this to set it differentiates against silence or background noise really. Um, and then you train a model like on what it's supposed to learn. So, but, well, yeah. So there's this thing, and you say, "Hey Ted," and you like you get a bunch of these together, and it's a spectrogram of the audio, right? So it's actually looking at like the waveform of that word, of that spoken word. And you do a bunch of that, and then you get a model at the end of that. And that model is yours. So I have a Hey Ted model right now,
Okay.
and I'm using something called TensorFlow. And now it's like changing names a lot, but it's basically TensorFlow Lite, and that is going to use that ML chip on the device and look at the waveform, not the way that I was trying to do speech to text, because that's like it like it works, but you can't break it into a wake word or like a single. You can't analyze basically because it's like a constant flow.
Right.
So the way that the speech to text works or speech recognition is very similar to what I just described, but it's on a different model. So when you do like a wake word, ideally you want to do like the waveform analysis or spectrogram analysis because then you're not doing all this overhead lifting. And what was happening was like it was crashing because it's doing way too much constantly. Because it's saying like listen for words. Does this word match this word? Does this word? So like constant analysis on the input stream was bogging down the device to a level that it's not even going to work.
So it's kind of like the difference between questioning suspects and facial recognition software.
Yeah, like yeah,
Like the
exactly.
first way we were doing it, it was like it was inspecting every word, making sure, blah, blah, blah. But this is like once we have the spectrogram, anything that fits it is scaled to automatically just be pulled out and acted upon.
Yeah, it's not listening for anything but what we want, and then it does that job, and it does that one job well, and then what we have is
So then are we using both essentially speech to text is just going to be left alone to do speech to text. This will be targeted just for hey Ted and good night Ted. And now we
yeah,
have two components doing two separate things, but in collaboration with each other like yin and yang to get to the goal line.
exactly, yep, and the one that we had before is used now for learning, transcription and learning. So it's going to also conversational stuff like if you wanted to just speak to the agent or the AI, then you can send voice and the speech to text will send that to our server and or it'll just send audio. Um, we have both actually, so we could test which is better and route that way. Basically, we have systems for everything. We built like a person.
So someone can take a picture and Ted does what? It detects what?
Like it could use your camera in real time and detect poses, facial recognition, stuff like that.
Wait, I'm just
It's
confused though. the facial recognition would have to be against a database. Like it's not like you could take a picture of a guy named Mark and Ted's gonna be like, oh, that's Mark Swanson, or does it?
No, you could have the app have a person take a few photos and train a model on it
Oh, what you're
on their
saying is
device.
the individual takes enough photos of an individual, Ted will recognize, oh, hey, there's Mark again.
Yeah, like kind of actually the iPhone does it with the facial thing, the facial
Okay.
recognition unlock. It makes you take a photo of like every angle of your face. And
Yeah.
then it's like
Okay. I like it.
that that builds a data set for them to train a model on your own device.
So do we already have that being built out? Like,
Yeah, so that's what we have like now, because like I keep going deeper and deeper. So like I'm like at first I'm just using Open API or OpenAI API, right? And
right.
we're just like sending them a ball of text and they're just like spitting back something. Now we're training models and the models can do a lot, like really crazy stuff. We could train it to recognize any image we want. We could train it to recognize any audio we want. We could um there was more. There's poses, like there's video, so you can do poses and facial recognition.
All right.
Like in a video call right now, we could have the AI recognize like your your body language, which
Right.
is scaring the hell out of me. But like that's where we're at right now. We're getting lower and lower control.
I know, I love that. And that's the whole point of this, right? So it's not like we're trying to compete with AI. We're trying to find a way to collaborate with. We're basically building what's this? A Johnny Five, like our version of like the bad machines, um,
Yeah,
which is totally cool.
I did have a little fun. I think like a week ago on the weekend, I made a visualizer. Like it's a I wish I could load the app, but I can't because it's broken. But maybe I could record a video of it when it's up and send it to you. But like it detects volume changes, and if you imagine like an old school tape deck or like
Right.
a amp, and how it's got the meters and they go up and down like the
Oh,
bar
shit.
graph.
Yeah, yeah, yeah,
I made that. So we have a old school bar chart, like volume meter, and then there's another one that's a straight line and it goes up and down in curves as they talk. Like,
that actually just solves something that's been on my mind, and I haven't brought it up yet because it's just like we're not there. But I was watching something or something, I don't know, and somebody was talking about how like kids are at a higher risk for being kidnapped, and like what do you do, yada yada yada. And my thoughts was always like, well, Ted would solve that because Ted would know the other person's voice is not the person. Like Ted knows I'm Steve's Ted, and now there's an altercation happening. And when Ted becomes reasonably certain that that Steve is being kidnapped, Ted would just call the cops and give them the location. The point is, so that kind of makes sense, but then it's kind of like, well, how do you do it? And the variables, I don't think would be many, but one of the variables would be voice volume and differential in frequency and tone and blah blah blah. Because to go ahead and confirm that this is an event that warrants calling the police, because Ted would have a baseline of like every time Steve talks, he talks like this. Now Ted would have a moment where it sounds like Steve's being kidnapped, and Steve just yelled like he never yelled before. Therefore, something different is happening. I think he's being kidnapped. He's never been kidnapped before. Kidnapping equals something different. Let's call the cops. And when you take that even a little further, you now have an opportunity to identify when people are telling jokes, when someone's friendly enough with someone that they pop out of the corner and say boo. Like there's, if someone's being intimate with someone, if someone has the hots for someone, they start talking differently. Like there's so many things that opens up. So to the point of us having the ability to do that, whatever your process was, take it to a 10 because that data set and that ability at a later date is going to be repurposed, and it's going to be quite important as a data set for kind of what I just described.
Okay, yeah, that sounds cool. I actually have a few ideas off of that. It's like there's like the accelerometer can detect movement, how you're holding the phone, what angle, what like it could develop a pattern of any sensor input,
That's
whether
all.
it's a microphone, a camera, accelerometer, like every single thing inside the
All right,
um,
we want all of that because when we go ahead and eventually like really roll this out, there will be some there'll be some type of marketing that needs to hit different demographics. And I think the world is going in such a way that nobody wants kids to have phones because they shouldn't. There's too much shit on a phone. But it's kind of like when you were young and you were able to sneak watching porn in between the lines. Like, there's some things you're never going to stop. Like, there is no reasonable deduction that the parental age is going to be able to refrain all children from using a phone. It's never going to happen. So if if the child's going to use a phone, then the compromise the parents could make is, yeah, you can use it, but Ted's already installed on it. That way, I know you're safe because the parent would have the confidence that Ted is Ted is able, Ted is Ted is your child's protector. So you want your son or daughter to have Ted because Ted will make sure that they're never kidnapped, they're never, if they're being approached by a stranger, if someone's talking to them in a weird way, all of this stuff, which which then kind of opens the door that is there going to be a parental thing on it, right? Like if the child's under 14, can you install TED on the child's phone and the report goes to the parents? I don't know the answer to that. I'm not opposed to it because I do believe in freedom of blah blah blah, but your parents are there to protect you. Like there's a
mhm.
reason. Like your brain is not fully formed at 14, and if you think it is, then you're even worse, right? Like so I don't look at it so much as like a violation as much as it is protection. I'm just kind of word vomiting now because the things that you're mentioning are actually filling in the blanks for a calculation I haven't quite got to in terms of variables yet. So even that stuff, go full force with it. We want all of it so that we can one day sit there and say, okay, we want to do this. How do we do it? We have these variables. Great. These are already data sets that we're able to train the model with.
Yeah, I think it's all about just what input we can get off of the sensors.
Yeah.
And I'm just looking through this site is like a bunch of it's like a YouTube of models that people train and put out for open source.
Oh, no.
But they've got stuff for like random things like this is like the liveliness of your face, like to tell if it's you, right? So like somebody put that out there. So it's just an example of like what's already there that we could integrate into what you're talking about.
I love that.
So if we can get the input, say a camera, and we have a model that can tell your face, the output is what you're saying,
Yeah.
the application of it. And that's like I think where it needs to go. And there's a lot of applications.
All right. Awesome. Okay. I think we're in a good place. Um, so for Monday, if we get something that's testable on test flight, and the definition being, can it download? Can Ted just chill for like 2 or 3 days? He's living on my phone. When I want to talk to him, hey Ted, what's up?
Hmm.
So, hey Ted wakes him. Good night, Ted puts him to sleep. And then, really, after 3 days, I want to ask him, hey, what did I have lunch on? What did I have lunch? What did I have for lunch on Monday? And he'll be like, oh shit, yeah, Monday you did this. Now that last part, I I would like it, but I could conceive a world where it's like, all right, we're not like that will be another 2 or 3 day thing. So you tell me. But in terms of like a successful, like this is exactly what we want, it would look like that.
Okay, sounds good.
So that
I'm
last
gonna
part
aim
could
for
be,
that.
so the last part could be included, right?
I think so. Yeah,
Okay, cool.
I'm gonna aim for that.
Yeah. Okay. All right. So then once we have that, we'll test it all next week. We'll identify, little things that we need to solve. Hopefully we can then, well, not hopefully, but like, because now we're kind of coming up on timelines. Um, we'll shoot and believe that we can solve that by next weekend, in which case it would be Monday. Let's see, today's the 11th, 12th, 13th, 14th, 15th, plus 7. It'd be Monday the 22nd. We can collaborate and say these are the things that we wanted to be able to do for October 1st. We'll discuss that with a 3 or 4 day cushion if we're wrong for anything. Um, and then October 1st, we'll have what we're looking for. So that's kind of like the timeline that's in my head, which I've built based on this call. So if that sounds reasonable, cool. If not, push back a little bit, but otherwise I think I'm okay.
No, it's cool. A lot of the stuff I feel like is just really close to being done, but I keep hitting unknowns. Um, I think they're all out of the way though. Like I can't really see anything hitting us that bad. Maybe a 3-day buffer is needed, but
Yeah.
I don't think
You,
anything was unreasonable.
you are the representation of anytime anyone ever asks me anything, I'm like, I don't know what I don't know. And it's
Yeah.
like, I've always said that sentence, but you are the living embodiment of it.
Yeah, I really am. And I have to go through these days blind. I'm just like,
Oh my God.
I don't know what's coming.
That's so funny.